All right, let's look at the addition principle. All right, this is very intuitive principle. All right, so if you want to know the number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersect B. All right, and if you use a Venn diagram, it's pretty easy to see this principle here. All right, so it says that, let's see, so we want to find the number of elements in this region here. So it's A union B, so this whole thing right here. All right, so this is A union B, right? What it's saying is that if you want to find the number of elements in this A union B, then what you need to do is we need to add elements in A, which is this much. So I'm going to just shade it in green here. All right, and the elements in B, so I'll use a different color. Elements in B, which would be something like here. All right. So you notice that we are counting the elements in A intersect B, which is in this region, twice. So that's why we need to subtract the number of elements in A intersect B, right? Because we're counting those guys twice. All right, so that's the addition principle. And another version is just a simple tweaking. We can exchange those two terms. So if you're looking for, we can just put this guy on this side. If you're looking for the number of elements in A intersect B, then this is going to be equal to number of elements in A plus number of elements in B minus number of elements in A union B, right? So we just tweak the equation a little bit, and we can have equation for the number of elements in the intersection. All right, so let's use this addition principle to solve the following example. All right, so we have a Venn diagram given, and there are some numbers given. So number of elements in A is 35. Number of elements in B in 70, and the number of elements in A union B would be 85, and the number of elements in the universal set would be 200. So that's the total number. All right. Then we want to find the number of elements in A union intersect B complement, right? So which is this region right here. So it's already shaded, but here. This is what we're looking for. Right, so what we want to do is, if I know, since we already know the number of elements in A, if I know the number of elements in A intersect B, we would be able to find the number of elements in A intersect B complement. Right, so let's find that. So we want to find the number of elements in A intersect B. So I'm going to use the second equation here. So number of elements in A is 35 plus number of elements in B is 70. And then we subtract the number of elements in union, so 85. Right? So this is going to be, so 105 minus 85 would be 20. Right, so we already know that there's 20 there. So 20 there. Right, so we have, say, number of elements in A is 35. So 35 there. So 35 minus 20. So this is 35 minus 20 will get us 15. Right, so that's the answer for part A. All right, let's look at part B. Actually, part B we already answered. Part B is 20. So here, 20 is there. Alright, so number of elements in A complement intersect B, which is these guys. So we're talking about those guys. Right, since number of elements in B is 70, and then you just have to subtract the number of elements in A intersect B, so it's 20, so that'll be 50. Right, so we have that. Alright, then last one, part B, number of elements in A complement intersect B complement. So we're talking about the this region right here. So we are talking about just the outside. Right, so this is going to be here, there. Right, so this is really the same thing as number of elements in A union B complement, right, which are just going to be number of, so you just subtract the number of elements in A union B from the total. So total would be 200. You're subtracting union, so 85. So this is going to be 115. Right? That's the answer for part B, part D. All right, that's it. I hope that this was clear.